Okay, so we are going to discuss conversion of infix expressions to postfix expression. Okay, so we'll start with one or two examples and then we'll look at how the algorithm actually works. Now, if you look at this particular example, this is an infix expression. Now, this is actually a string, or you can read this expression or this string one character at a time. So, what we do is uh, we've already seen when we were discussing infix, prefix, and postfix expressions, we have already seen that when we consider these three expressions, the relative order of the operands do not change. When you look at all the different types or different notations for expressions, we've seen that മൂന്ന് കേസിലും അതായത് ഇൻഫിക്സ് ആയാലും പ്രിഫിക്സ് ആയാലും പോസ്റ്റ്ഫിക്സ് ആയാലും the order in which the operands are there in these three notations are the same. So when you come across an infix expression and you want to convert it into postfix, if you're reading an operand, the only thing you have to do is just output it into the postfix expression. Okay, so here we start on the from the first character. Okay, first we are reading A, and we know this is an operand. So what do? We output it. That is a general rule. So whenever we come across an operand, just output it into the postfix expression. Right. Now we move on to the next character, which is an operator. Okay. So when we are talking about operators, uh, when you take an operator, it is actually not possible to decide at this point whether this has the highest priority. Highest priority ഉള്ള operators ആണ് നമ്മൾ ആദ്യം evaluate ചെയ്യുന്നത് അല്ലെങ്കിൽ ആദ്യം output ചെയ്യുന്നത്. So at this point in time, we are just reading one operator. Okay, at this point in time, it is not possible to take a decision whether to evaluate it or not, because it can only be evaluated if it has higher priority than the operator on its right. Say for example this. So if you look at this, if you look at plus and star, since star has a higher priority, it will be that operation will be done first, right? So we don't know. So whenever the general rule is, whenever you come across an operator, you cannot decide at this point in time whether it can be evaluated right now or not. So what we do is, it will be saved somewhere, and what we're using is a stack. Okay. So what we do is, we read plus, we don't know whether it can be evaluated right now, and so we save it in a stack. Okay. And also, so we said when we read an operator, the decision about that the current operator cannot be taken now, and we will push it into a stack. Okay, so even if we are not taking a decision about the current operator, but we have to mention here that at any point you read an operator, okay, you can take a decision about those operators to its left. Okay, those operators to its left. അപ്പോൾ ഇവിടെ നമുക്ക് ലെഫ്റ്റിലേക്ക് ഓപ്പറേറ്റേഴ്സ് ഒന്നുമില്ല, but we'll come to it later. Okay, so we have considered plus, so we can't take a decision about plus right now, so we are pushing it onto the stack and we are moving on to the next character, which is an operand. So operands, we are just outputting it, so we'll output it here, and we move on to the next character, which is an operator. Again we have come to an operator. So regarding operators, we said regarding the current operator, we cannot take a decision, but we can take decisions about those operators to its left. And those operators to its left will always be there on the stack. Okay, so what is the decision which we can take? And that is what is mentioned here. So if an operator is found, if the operator in the stack has higher or equal precedence than the current operator. Okay, if the operator in the stack has higher or equal precedence than the current the operator, then it can be evaluated or output. Okay. അപ്പോൾ നമ്മൾ കമ്പയർ ചെയ്യുമ്പോൾ you're comparing the current operator star and those operators in the stack, and if the operator in the stack has higher precedence, then this can be output. അപ്പോൾ ഈ കേസിൽ അതല്ല, because plus has lower precedence, right? So in that case we go to the else part. We simply push the current operator in the stack. So if the operator in the stack has lower precedence than the current operator, you just push the current operator on the stack. So what do? We will push star here. Okay. Now again we come to another operand. Operand കാണുമ്പോൾ just output ചെയ്താൽ മതി. Now moving on to the next operator, which is a minus. So when operator is found, if the operator in the stack has higher or equal precedence, then what do? We can output it, right? So here we are comparing minus is the current operator and star. So star has a higher precedence, so you can pop it. Okay, popping we will just show by putting a cross here and outputting it. Similarly, we will look at other operators in the stack. Okay, so plus and minus are also compared. So when you compare plus and minus, plus is an operator which was on the left, right? Although plus and minus have same precedence relations, but plus is, if you think about the associativity part, okay, you have a less associative way, right? Even if they are of the same precedence, so plus will be executed first, right? So again you're popping this and outputting it. Okay, so as long as you have operators within the stack, you compare, and if they have higher or equal precedence than the current operator, you can pop it out and output it into the postfix expression, right? After that you push the current operator onto the stack. So minus has to be pushed onto the stack. Okay, right. Now we come across another operand. So our operand നമ്മൾ output ചെയ്തു. So now we have come to the end of the string or end of the expression, infix expression, and in the algorithm which we are going to study, the end of expression is denoted by a closing bracket. Similarly, stack before we start, an opening bracket is also placed. So when we encounter the end of the string, the algorithm, what it does is it will go to the stack and pop out all the operators in the stack until the opening bracket is encountered, which in our case we just have to pop out this minus, okay, and output it. Okay, so this is the general algorithm, right? Now can we look at this a plus b into c? Okay, that we have already considered. Okay, anyway, a plus b into c, if we look at this, how does it work? You look at a is an operand, so you output it. Then you come to plus, which is an operator. So okay, we said already there will be an opening bracket here, that is the algorithm specification, and similarly a closing bracket at the end of the string also, and you're pushing plus. Okay, pushing plus. Then we come across b is output. Next we come across star. So star is another operator. So what do? We compare it with the whatever is there on the stack. Since it has lower priority, what do? We just push star. Okay. Higher priority ആയിരുന്നെങ്കിൽ we would have popped out. But since plus has a lower priority, we push the current operator onto the stack. Okay. And then we come across C. So C is also output. Now we come across the end of the string character, which is the using brace. So when that happens, what we said is pop out all the operators and output it. So first star comes and then plus comes. Okay, so if you look at it, so BC star will be evaluated first, and after that, okay, so now we have a general idea about how the conversion of infix expression into postfix expression works. But one thing we have to mention here is about the precedence values. We have been comparing the precedence of the current operator and that in the stack. So how do we keep track of those precedence values? That is what we are going to look at next. So here, here we have the different operators we are talking about. You have plus, minus, multiplication, division, exponentiation. These are the operators we commonly see in arithmetic expressions. Okay, so here plus and minus have the same precedence level. Similarly, multiplication, division have same precedence and so on. Now we have two sets of precedence values given: in-stack precedence value and incoming precedence value. Incoming precedence is the precedence of what we call the current operator we are processing. Okay, current operator in the infix expression. So അതിന്റെ priority ആണ് ഇവിടെ കൊടുത്തിട്ടുള്ളത്. Now if you look at this, the priority in the stack is one higher than the priority here. Okay, plus minus എടുത്തു കഴിഞ്ഞാൽ this is 1 and this is 2. So the one in the stack has a higher priority. So one in the stack means the operator in the stack. If you think about it, the operators in the stack are the ones which are to the left of the current operator. So since plus and minus are actually left associated, so the one on the left has to be evaluated first, right? So that is why the in-stack priority value is higher than the incoming priority value in the case of the same input symbol itself. Now, if you look at exponentiation operator, here, if you see, the incoming priority value is higher than the in-stack priority. This is because exponentiation is right associated. So, this is how the precedence or priority values are maintained in order to compare for the algorithm. Okay. Now that we have seen it, now we can move on to the actual algorithm itself. Okay. So, algorithm takes input E. E is a simple arithmetic expression in infix notation and it is delimited at the end by the right parenthesis symbol. Incoming and in-stack priority values for all possible symbols are also taken as input by the algorithm in a table. Okay. Now, what is the output? Output is an arithmetic expression postfix notation and the data structure used is a stack. Okay. Now, what happens initially? Now, initially what happens is you push uh, opening braces onto the stack, right? Okay, as we said, to start off, we push the opening brackets onto the stack. Now, as long as the stack is empty, there is something on the stack. Okay, so we read one input symbol and that is placed in item. Now, you pop out the top of the stack in order to compare with the current symbol. Now, if the item, if whatever is read is an operand, we already said if an operand is read, you just have to output it onto the uh, postfix expression. So you don't have to do any comparisons with the x value popped out. So you push this back onto the stack. Now, in case this item is a closing symbol, okay, then in that case, it might be, this might happen when you reach the end of the infix expression or maybe if there are brackets in between also. Okay, so in that case, what you do is you pop out all the operators until you encounter a opening brace. Okay, all those all those operators are popped out and output onto the postfix expression. Right. Now these are the two cases where we are comparing the priorities. In-stack priority and incoming priority are compared. So earlier, okay, what we said is if the operator in the stack has higher or equal precedence, the operator in the stack has higher or equal precedence, then you have to pop out an output, right? So that is what is given here. If in stack priority is greater than or equal to the incoming priority of the current operator, then you pop out all those operators in the stack which has a higher priority than the uh, current operator we are processing. Okay, and then push it. അത് നമ്മളിവിടെ എഴുതിയിട്ടുള്ളതും അങ്ങനെ തന്നെയാണ്. Then push the current operator onto the stack. The same thing which is written here also. Push the current item. Now this push X is because you have an extra pop here, right? So that is also pushed on. The extra pop comes here also, right? Okay. Now in case in stack priority is less than the incoming priority, you just have to push this item. So this is the general algorithm. So you read a symbol. If it is an operand, you just have to output the item. If it is an operator, you have two cases. That is, if the in-stack priority is greater than or equal to incoming priority, you have to pop out those items and output the postfix expression. If it is less, if the in-stack priority is less than incoming priority, you just have to push the item. And in case you encounter a closing bracket, then you have to pop out all the operators till you encounter opening bracket. Okay, so this is the overall picture about the algorithm. Okay, so now that we have seen the overall picture about the algorithm, we look at an example. Okay, so this is the infix expression on which we are going to try our algorithm. Now these numbers are just indices, and here in this diagram, uh, when you're reading one, what is the condition of the stack and what is the condition of the output? So all these things are given in this picture, and here we have the priority values are also given in case we want to refer to it. Okay, so initially we said the stack will have the opening braces, and there will be the as last operator or last to indicate the end of the infix expression. There will be a closing bracket also. So that is where we start. Now we will read the first symbol, that is again an opening bracket. So it is not an operand, right? So if it is not an operand, you compare the in stack priority of whatever is at the top of the stack and incoming priority. So both symbols are actually on the stack. We have an opening bracket. Whatever we are reading is also an opening bracket. So in stack priority is 0 and incoming priority is 9. So in stack priority is lower, right? When in stack priority is lower, we know we have to push the current symbol onto the stack. That is what is done here. There is nothing that is output. Okay. Now we move on to the next symbol, number 2. That is when 2 is read, what happens? So it is what we are reading. 2 is actually an operand. So the algorithm says when the operand is read, you just have to output it. So it is output here. Okay. Now we move on to the third symbol, which is plus, which is an operator. So when an operator is read, we have to compare in stack priority of top of the stack and the incoming priority of this operator. So the in stack priority of uh, whatever is on top of stack is the opening bracket is 0 and incoming priority of plus is 1. Again, we have a lower priority on the stack, which means you have to push, right? So we pushed, that is when symbol 3 is read, you push plus onto stack, output doesn't change. Okay, now next is you read B, which is again, it is fourth symbol. When fourth symbol is read, stack is like this, and you output B onto the postfix expression, right? Okay, next symbol is 5, that is closing bracket. So we know when a closing bracket is encountered, what the algorithm says is you have to pop out all the symbols on the stack until you encounter an opening bracket. That is, you have to pop out plus onto the output. That is what happens, right? So this opening bracket is also popped, which means you only have uh, the the opening bracket here, which you place there initially. Now we move on to the next operator, which is the exponentiation. So when an operator is encountered, again you compare the priorities. It is 0 in the case of opening bracket and exponentiation is 6. So again you have to push, right? Okay. Now C is an operator. So when 7, symbol 7C is read, you just output it. Now you encounter minus. So when minus is encountered, what happens? Minus is an operator. So minus, the priority of minus and that of exponentiation is compared. In-stack priority of exponentiation is 5 and incoming priority of minus is 1. So this has a higher priority. Higher priority on the stack means you have to pop it, right? Pop it onto the output. So that is why if you look at this, this is a symbol when 8 is read. That is here. When 8 is read, what happens is you pop out exponentiation operator onto the output and then you push minus here, right? So like that you can actually go through the whole output and see how this works. Okay, thank you.